Hey guys, so today in this video I'm going to go over Quicksort. So Quicksort is a sorting algorithm that uses recursion and the divide and conquer technique. Another sorting algorithm that uses recursion would also be merge sort. There's going to be multiple different sorting algorithms that you have to choose. Selection sort, heap sort's a good one. But one of the top efficient sorting algorithms is going to be Quicksort, especially if you do it properly. So when you're going to interviews and things like that, Quicksort, it would be really tough to memorize the code. But if you understand what's going on and understand the algorithm, you can drive it pretty easily. So let's dive in and let's go over a quick overview of kind of what Quicksort is going to do. So Quicksort will kind of have an array here. So it's going to sort an array, and it's going to be in ascending order. That's the goal. So Quicksort, like I said, divide and conquer technique, it is going to take this array and it is going to recursively turning this into subarrays. I don't want to write subarrays, but let's just kind of get chunks of the array. And it's going to keep recursively calling till it gets down to a single element. So that's the overall high-level idea of what Quicksort is doing. Divide and conquer, taking an array, dividing it into subarrays, and basically sorting those little arrays. Okay. So let me write this back up here actually. Quicksort. Okay, so let's actually get an array going here. I don't know how many values I want, but let's just go with, that sounds like, yeah, that looks good. Okay, so let's just throw some random values in here. 8, 3, 9, 1, 6, 4, 2, and let's go with 7. Okay. Okay. So in your Quicksort method, so basically you're gonna usually call by convention our partition method. So you're usually gonna call a partition method and then you're gonna pass in the new subarrays and do the Quicksort method recursively. So the variables that we're gonna have, so just by convention, you can choose whatever you want. I'm just going to go with I and J for over here. Usually it could be left, right, low, high. I'm just going to go with I and J. And then the big variable that you're going to focus on would be what's called a pivot. Now the pivot is where you can get creative and you can keep making this algorithm more effective and more efficient. So the pivot doesn't really matter which one you choose in a sense for the algorithm to work, but to make it more efficient, there is ways of choosing the pivot. So I'm just going to choose the first index in the array. You could choose the last index in the array. You could choose the middle index in the array. A good one would be to take the first index, the middle index, and the end index and actually find the middle value and use that for the pivot. So that's usually a good idea. And there's lots of ways of implementing Quicksort, but this is going to help you understand, and this is one of the popular ways to do it. Pivot, you can look into, hey, what's a better way to choose my pivot value? But today I'm just going to use that first index there. Okay, so what we're going to do, what you're going to be coding in your method is you're going to want to keep incrementing I by 1 until you get to something that is less than the pivot. Okay, I'm sorry, that is greater than the pivot. Okay, and then you're going to keep decrementing J until you get to something that is less than the pivot. Okay, and you're going to keep doing that as long as I is less than j. And I'll tell you what happens when I is less than j. When these basically swap sides, that's when we're going to basically back out of this partitioning method. So what I'm going to go over here is this is your first step. This is going to be the partitioning. And basically our goal here is to take our pivot value, which is 8, and we want to find where this belongs in the array. So if we look at our array here, we should have 1, 2, 4, 6, 7, 8. So I think that's correct. But we basically want to get 8 here because that would be in its sorted position. So basically our goal is to get this value, where the pivot is, find its place, and then divide the array into subarrays. Now when you're, like I said, our best case would be getting the value that belongs here and then splitting it into 2 equal arrays. That's the best case. That's why a lot of times you want your pivot to be the middle value, but in an unsorted array, you're not really going to be able to find that effectively. So a lot of times you're just going to kind of guess. But we're just going to take the beginning value. So yeah, anyways, we're trying to get 8 into its sorted spot, which is here, because I can just see this is a small array. So let's do that. So what we're going to do is we're going to keep incrementing I until we find a value that is greater than the pivot, okay? So pivot right now equals 8. So let's increment I by 1. Okay, so I equals 3 right now, which is not greater than 8. So we're going to keep incrementing it by 1. I is at 9. I is equal to 9, which is greater than our pivot. Awesome. So that's good. We found a value that is greater than our pivot. Now we're going to hop over to j. J, we need to find a value that is smaller than our pivot value. So j, it is already on a value that is less than the pivot. Perfect. So we're good. So since I is less than j right now, as far as the index value, we're going to call our swap method. We're going to swap these values. The swap, when you're coding, is a pretty easy method to code up. You're just swapping the values in the array, 7, 9. Okay. And we just keep doing that. So after our swap method, let's go back and do it again. I plus 1 until we find something that's greater than the pivot. I is equal to 1. That is not greater than the pivot. Let's keep incrementing by 1. That is not greater than the pivot. Keep going. And this time you're obviously just going to keep going until you get to 9. So I is equal to 9. So we found something greater than the pivot. Now let's move over to j. J, we need to find the opposite approach. We need to find something that is less than the pivot value. Pivot value is 8. So let's decrement by 1. Okay, so 2, j is equal to 2. 2 is less than our pivot value of 8. Perfect. Let's swap. No, we're not going to swap. That's what we would do, but remember, as we're going to do the swap, I and j, as long as I is less than j. But now that they've flipped sides, I is not less than j. So this is when you're coding, you're actually going to want to swap these guys. This is where you swap your pivot value, 2 and 8. Now when you're coding this up, so let me make sure this is right. I bet you I guessed wrong. So 1, 2, 3, 6, 7, 8. I'm doing something wrong. 1, 2, 3, 4, 6, 7, 8. Okay, sorry guys. So yeah, this is the correct spot of the array. I goofed up in the beginning there. I don't know why that was so hard for me to predict, but 8 is in its correct spot. And we can tell because everything to the right of 8 is larger. Everything to the left of 8 is smaller. So this isn't sorted, but everything to the left is going to be smaller. Everything to the right of J is going to be larger. Now J, when we get to this part, when we're coding, J is what we were looking for. Because this is basically the value that helps us partition the array. So when we're actually coding this, we're going to pass in our quicksort method. We're going to use J to help us out, to basically call quicksort on this half. So basically call quicksort on this half. And call quicksort on this half. Now this is a good example of not picking the best pivot value, because you can see we're splitting the workup on the left, but this is already sorted, okay? So we're gonna pass that into quicksort and it's gonna be like, hey, it's gonna spit it right back out and it's gonna be done. So this isn't a very good example this is a good example of not picking a good pivot value. Now, if we would have picked a pivot value that would have ended up in the middle, and then we can split this in half, then the work is divided equally. And that's what we want. We want the recursion to help us divide the work equally, divide and conquer. So when this is the partitioning method that we just went over, our goal was basically to get that pivot value, find where it belongs, and then return it. We're going to return J. We're going to return basically the partitioning index, so that the method knows where to split the array up. Okay, so you're just going to keep calling that. You're going to call quicksort on this guy. And then you're going to call quicksort on this guy. And I'm just going to write the quick code of what your quicksort method will look like. So remember, that was the partitioning method that we called and that I went over. And our goal was to get that pivot index or that pivot value in its correct location and then split the array. Okay, so what our quicksort method will actually look like. Int, let's just do the same thing, int J. And I could probably use better variable names like low and high, but that's okay. Let's just end it with our bracket down there. So in your quicksort method, you're going to be passing two variables or two integers. It's going to be the low index of the subarray and the high index of the subarray. So we're going to start out by saying if I is less than j. If I is less than j, then we are going to I'm just going to say partitioning index, but this is where you're going to call that partition method. Partition, and I'll probably have the code, the source code linked at the bottom, partition, and we're going to pass in I and j. Okay, I'm not going to go over the partition method as far as the code. I've explained it pretty well. Like I said, I'll have the source code in the bottom. So we want to find that partition index. Okay, so this will basically be returning, it'll be returning that j value that we found, that partitioning index, but I'm going to store it as the letter P. But this is the method that we just went over. And then as soon as we get that, this is where we're going to recursively call quicksort. And P is going to be, so we're going to pass in I. Now I is always going to be the lowest value in the array. So we're splitting this array and we're finding P. P is the kind of the middle guy that we want to help split up. So we're going to do I to P. And then we're going to recursively call quicksort again. except for p plus 1 to j. Okay, and that is the end of our if statement. Okay, so let me go over this one more time. So obviously in this example, you're not passing in the array. This method would be in your class that has your array. That way it can globally access your array. You would have to create an instance of that array to use this method. So a lot of methods you might see that you actually have to pass in the array. This example, I'm just assuming that you can access the array from this method. Okay, so you're going to pass in basically the low index and the high index. This is going to keep recursively quick sorting until you get to your base case. Your base case is basically, it's saying if I is less than j. Your base case is if I is not less than j. You know, I don't have it coded up here because that's just a waste of code because you don't need it, but it's going to keep calling this until I is not less than j. That's our base case. Because when I is not less than j, basically you're going to have I and j are basically going to be equal to each other. That means you're going to keep recursively calling this until you get down to one single subarray that only has one element in it. So that's kind of the goal of Quicksort. But yeah, passing in the low index and the high, and then saying, hey, as long as it doesn't look like this, then let's partition that partition method that I just went over. We're going to partition it to get that pivot index or that pivot value where it should be, and then we're going to partition the array into subarrays, and then we're just going to keep calling the Quicksort method on the left half. That's what I to p is. Basically, I to where we found the pivot was supposed to be on your left. We're going to quicksort that, and then we're also going to quicksort the right side. And we're just going to keep doing that until we get to one element. And then that is how Quicksort is going to work, and it's going to sort your array. All right, so I think that's it. Thanks for watching. Leave any comments if you have any questions in the bottom. Thanks.